Hi guys, welcome to your focus notes video of today. The title of today's notes are going to be angles, degrees, and radians. So we already know what a degree is, but we're going to be learning a couple things regarding how to sketch degrees all the way to how they relate to radians and what even a radian is. Okay, so the first thing I want you to do, you don't have to copy this down, but I do want you to try this on your own. I want you to go ahead and pause the video after I give you your instructions here. I want you to sketch the angles 30 degrees, 50 degrees, and negative 60 degrees in your notes. Okay, so go ahead and pause the video, sketch those angles real quick, and then come back to the video. Okay, so chances are you probably were a little confused as to where you were going to start. You probably know what 30 degrees looks like, what 50 degrees looks like, maybe even what negative 60 degrees looks like. You maybe did not know where to start. So to sketch an angle, what you want to do is you want to start at the positive x-axis, and then you want to rotate up 4 positive angles, and then I'll put rotate down for negatives. Alright, so for example, if I wanted to sketch 30 degrees, I would start with my x-axis, and I would say, alright, well, where's the positive x-axis? The positive x-axis, it's going to be the right side, the x-axis on the right side, okay? So I'm going to start here, and I'm going to put my initial side here. You can't really see it, the starting point of my angle. Then I'm going to rotate 30 degrees up because it's a positive angle, so I'm going to rotate 30 degrees up right around there. And then I'll go ahead and sketch my angle right there. That's going to be my 30-degree angle. Okay? It might look a little bit larger than that, but again, these are just sketches. We're doing the best we can. Alright? Over here, let's go ahead and try the same thing with my next angle, 50 degrees. Again, we're starting on the positive x-axis, and then we're rotating up because it's a positive angle. And we're going to go all the way up to 50 degrees this time. That should be right around there. And then I'll go ahead and draw my terminal side, and that's going to be 50 degrees. Okay, so if we're labeling here, this is where we start at is what we call the initial side. Where we end at is called the terminal side. So go ahead and label that in one of these examples. Start and end, initial and terminal. Okay, so that's all that means. Fancy words for those. The last example I wanted to give you before we move on is the negative angle. So again, we're still starting on the right positive, but now we're going down 60 degrees, so I'm going to rotate down 60 degrees and end right there. Terminal side goes right around there. That would be theta equals negative 60 degrees. Alright, so now that you have some examples on how to sketch an angle, I want you to go ahead and complete the sketches for these 4 angles here. Remember, each quadrant is 90 degrees, so 120 should be 30 degrees past that 90 degree angle. 250, you got to do the math and see what quadrant it ends up in, but sketch them as closely as possible to their actual values. Also, don't forget, remember the negatives, you rotate down instead of up. So pause the video here and complete those sketches before you move on. Now to one of the most important parts of today's lesson, the definition of a radian. So what is a radian? Well, there is a different definition that I could give you. It's a little bit more technical, but this is really all I need you to know. What's boxed in here. First of all, you need to know that a radian is just a different unit used for measuring angles. So we typically use degrees for measuring angles. We know 360 degrees makes a full circle. A half a circle is 180. A quarter of a circle is 90 degrees, so on and so forth. Well, here we're going to define pi radians. The radian as pi radians is equivalent to 180 degrees or half a circle. So remember, pi is around 3.14. 3.14 radians is about half a circle. It's equal to half a circle. Okay? So that's pretty much all you need to know about radians right now. There's a more technical definition that we'll go over at some other point in class. But for now, pi radians equals 180 degrees is all you need to know. So pause the video real quick, and what I want you to do is I want you to sketch pi radians in standard form, in the form that I showed you how to do earlier. So go ahead and pause the video real quick and sketch pi radians. Hopefully you were able to do this on your own, but remember we start on the right hand side, and then pi radians is 180 degrees, so we're just rotating 180 degrees in the positive direction, and we're ending here. So it's like a straight line. If it was a straight line, both the initial and terminal side. This is pi radians. Okay, so it's the same thing as 180 degrees. All right. So now, again, I want you to try to pause the video, and I'll show you guys the answers just after you press play. But I want you to go ahead and sketch the following angles. And I want you to sketch the angles knowing that pi radians is 180 degrees. Work your way down from there. There should be 3 separate angles, but you should be working your way down. Pi radians is 180. So if I take pi and divide it by 2, what would that look like? If I take pi and divide it by 4, what would that look like? If I take 5 pi and divide that by 4, what would that create on the circle? So pause the video now and try to sketch those 3 angles on your own. Alright, so hopefully you were able to get at least a guess now, and you can modify that answer based on what you see from the results here. So remember, since pi is 180 degrees, or half a circle, like we saw up here, pi halves will be half of that. So what would that look like? Well, it's starting here. Instead of going half of the circle, it's only going to go a quarter of the circle now, and that is going to be pi over 2 radians. Just a side note here, sometimes we put rad for radians, other times we just leave it alone as pi over 2. We don't really need to put a symbol. Whenever we see pi involved, that's how we know we're talking about radians instead of degrees. Okay? So now we're taking pi over 4. We're doing pi over 4 radians. So if I cut pi, which is half a circle, into 4 sections, it's going to look like this, starting here, ending here. That's a fourth of the circle. So theta equals pi over 4. And I meant to say a fourth of the half of circle. Because again, pi is 180, or half of that. Alright, now what about 5 pi over 4? This one gets a little bit tricky. But we should know that we can cut this half a circle into 4 sections. Okay, so I'm going to go ahead and do that real quick. I'm going to cut it into 4 sections. These are not going to be my initial or terminal side. Just going to put four little tick marks, cutting them into fourths. So there's a little tick mark there for 1/4. There's 2 fourths. There's 3 fourths, and then the slide would be 4 fourths. Excuse me. And then finally, if I keep going, 5, 6, 7, and 8. So remember, that tells me how many fourths, how many pi fourths I have rotated. So I'm going to start on the right hand side, and I'm going to rotate until I get to 5, my desired value. So I'm going to go 1, 2, 3, 4. That's 4 pi over 4. I need to go 1 more to get to 5 pi over 4. And that is how I get my 5 pi fourths radian sketched. So let's go ahead and get some more practice with this. We're going to sketch the following angles, and they're going to be listed in radian. So we're going to start with pi over 3, and then we're going to move over to 2 pi over 3, and let's end up with 4 pi over 3. And there is a way that we can do this by splitting the section into pi into the 3 sections that this is telling me to do. Graph 1 of those sections here, 2 of those, and 4 of those here. But instead, let's just think of this conceptually. If I split pi up into 3 sections, or take 1/3 of pi, remember pi being a half circle, I'm going to end up with this. If you could see here, if I continue, my second section would be right around here, my third section would be right here, and that would be splitting it up into 3 sections. So from here, my initial side, to here is going to give me pi over 3. Alright, my second one, 2 pi over 3. Now I'm going 1, 2. If I split pi up into 3 sections, my second section would land somewhere over here. So that angle formed would be 2 pi over 3. And lastly, if I take 4 of those sections, this is where it gets a little bit tricky. Remember, if I'm doing 3 of those sections, 1, 2, 3, it's going to land me at pi over 3. So I need to do one more of those pi thirds sections. So I'm going to go about that same angle that I found here, except in the third quadrant, which will leave me right around here. So starting there, ending there, that will be my 4 pi over 3. Okay. Now, let's see what these angles are. I will switch to a different color now. In degrees this time. So in degrees, remember, we're taking pi and we're dividing by 3. Well, since pi is equal to 180, this angle in degrees is equal to 180 divided by 3. If you do the math, you can pause real quick to do that math. 180 divided by 3 gives you 60 degrees. In other words, pi over 3 radians is equal to 60 degrees. Alright? So again, now we can say, alright, well, this was 2 of those sections. We know pi thirds is 60 degrees, so 2 of those sections, 2 of the 60 degrees would be doubling that 60 degrees, which gives me 120 degrees. That will be that section. And then lastly, this is going to be 4 of those sections. So we can multiply 4 times 60, and that could give me my answer. Or we can say, oh, well, pi is going to be 180, and then we're adding one more of those sections which we got right here, which was 60. So 180 plus 60 gives me 240 degrees. That's what theta equals right there. So now we're going to focus on the conversion between radians, from radians to degree, and we'll go back over in just a bit. But again, to remember that conversion, all you need is that pi equals 180 degrees. That is all you need to know. So when you're converting from radians to degrees, all you have to do is substitute 180 degrees in for pi, because again, those are equivalent. So let's say I wanted to go ahead and say convert 2 pi over 3, which we already found in the previous example to be 120 degrees. I want to make sure I can use a different method to go ahead and find that. Instead of graphing it and kind of looking at it conceptually, I want to go ahead and have an algebraic computational way to do it. So remember, I'm replacing pi with 180 because those two are equivalent. So 2 times 180 over 3 is what it's going to look like. Okay? So before I go ahead and complete this calculation, I'm going to go ahead and simplify 180 into 3. 180, 3 is divisible by 180, and they're both divisible by, obviously, 3. So 180 divided by 3 is 60, and that's going to reduce that down to a 1. 3 divided by 3 gives me 1. So all I have to do is multiply 2 times 60, and that's going to give me 120 degrees. That's how easy it is to convert from radians to degrees. Alright, so now that you've seen a couple examples for converting, now I want you to go ahead and try the practice for those 3 problems. Go ahead and convert those radians to degrees. Remember to simplify with your denominator before you go ahead and multiply. It's going to make your number smaller. It's going to make it easier. And remember, you're going to have to reduce until you can't anymore. If you simplify beforehand, then you won't have to be reducing as much. Okay, so pause the video here, complete those practice problems. Okay, now let's go ahead and move on to the reverse of that, which is degrees to radians. Degrees to radians is a little bit more complex. It's not as easy as just substituting a value in. So when you convert from degrees to radians, to see what it is in radians, you're going to multiply by a fraction, which is pi over 180. Remember, these two are equivalent. We're just getting rid of the degree symbol. We're kind of canceling it out. That's why the 180 is on the bottom. And we're introducing the radian symbol, pi. Okay? So we're going to go ahead and complete this example. We're going to convert 75 degrees into radians. So to do this, we're going to multiply by that fraction pi and over 180. Remember that before we actually multiply this, we want to reduce the 75 and the 180. Since both of these terms are divisible by 5, we'll divide both of them by 5. 75, or 5 fits into 75, 15 times, and 5 fits into 180, 36 times. So completing this process, remember I'm multiplying the term on top with pi, so 15 times pi is 15 pi over 36. So in other words, 75 degrees in radians is equal to 15 pi over 36. Alright, so go ahead and practice converting these two angles in degrees into radians. Convert from these two 300 degrees and 270 degrees, convert them from degrees to radians. Pause the video now. When you're done, continue to the next portion. Alright, let's go ahead and move on to the definition of coterminal angles. So coterminal, I've written it like this because they share a terminal side, an ending side. That's really the definition. Coterminal angles share a terminal side. Angles that share a terminal side. So, what does that look like? Remember, we always start measuring an angle from the right side. So, from the right side to the terminal side, we can rotate in different ways. We can rotate up to get there, or we can rotate down together. Both of these are not the same angle. They're not equal to the same value, but they are coterminal, meaning they end up in the same place. So the same happens over here, and something we haven't discussed yet. If you haven't figured out by now, if your angle exceeds 360 degrees, then you just spiral and keep spiraling until you get to your ending angle. So right here we have a positive angle that exceeds 360, and then goes all the way to the third quadrant. A coterminal angle for that would be a negative angle of rotation that ends in that same spot. So that's what coterminal means. Alright, so we're going to go ahead and start with an example here. With the angle of 443 degrees. Okay, so if I graph 443 degrees, this obviously exceeds 360 degrees. So I'm going to, again, start on the right, and I'm going to rotate 360. And what I want to ask myself is, how many more degrees do I have to rotate in order to get to 443? And the answer to that is 83 degrees. So right around there, 7 degrees short of 90. So that is 443 degrees. So if I wanted to find an angle that is coterminal to that, I just have to look at the leftover part from 0 degrees to get to that terminal side. So I can still rotate in the same direction, and that angle right there would be my coterminal angle. I denote it with a little prime, meaning my coterminal angle to that is theta prime, which was the 83 degrees that I needed to get to that last portion. So 83 degrees would be my coterminal angle that would be coterminal with 443 degrees. Alright, so go ahead and what I want you to do now is I want you to spend some time sketching these two angles and finding coterminal angles that are between 0 and 360. In other words, coterminal angles within one revolution, one positive rotation of the circle. So go ahead and pause the video now, find those coterminal angles, and continue watching once you have found the coterminal angles of those two angles. Alright, so now we're going to move on to radian coterminal angles, and this is where we'll end the day. To find coterminal angles for radians, there's actually a couple ways to do it. But I'm going to show you the graphic way, okay? So how to do this with a graph. So what we want to do is we want to sketch this angle first. So to sketch 23 pi over 9, the most concrete way that I can show you is to realize that we're splitting up pi 9 ways, and we're sketching 23 of those sections. So splitting pi up 9 ways, remember, since pi is 180, I need to split up half of this circle, half of this grid, 9 ways. So I'm going to start here, 1, 2, 3, 4, and I can't count that one. So 5th section is going to be here, 6, 7, 8, and then 9th section is going to be the line. Okay, so that is 9 equal sections, 1, 2, 3, 4, not counting the middle one, 5, 6, 7, 8, 9, counting the last one. Okay, since I know that actually if you can if you've been doing this for a while, you're going to be able to figure out that's going to be more than half a circle. So I'm going to go ahead and duplicate these same lines on the other side. Since I've already done them once, I'm going to go ahead and just do them again and just continue them to the other side. Alright. Okay, so now I've gotten all of my sections. There should be 18 total because 9 on top, 9 on bottom equals 18. So 18 of these pi 9 sections to get to a full circle. Alright? So now we're going to go ahead and sketch my angle 23 pi over 9. So I'm going to count 23 of those sections. Remember, I'm not counting the y-axis here. So I'm going to start going quickly here, or slowly, and I'll build my way quickly. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, that's 9. And I know another 9 is going to give me 18. That's 18 right there. And I need to figure out how many more do I need to go and to get to 23. And that is 5 more of these sections. So I'm going to stop at 1, 2, 3, 4, and 5. So that is the angle 23 pi over 9. That's the sketch of it. Now I want to find theta prime. And again, theta prime, I want to find it between one full rotation. So that's going to be between 0 and then one full rotation. Since pi is half a circle, 2 pi would be a full circle. So I'm going to start here at 0, and I'm going to end at the same terminal side, being this one right here. So I'm going to go ahead and rotate, and then I'm going to count how many of those sections were there. 1, 2, 3, 4, and 5. So my angle, my coterminal angle is 5 pi 9 sections, or 5 pi over 9. Okay? So I don't have, I won't leave you with any practice. Hopefully that was a good enough example. And for the rest of class today, whatever time you have left, I want you to go ahead and work on the assignment posted on Google Classroom that is titled Homework, Angles, Degrees, and Radians. So you're going to be doing some sketching, you're going to be doing some converting, and you're going to be doing some coterminal angles there. Okay? This assignment will be due at midnight of the next class. Don't forget to post your focus notes for this presentation. That will also be a grade. And again, it's due the same day as the homework, midnight of the next class. I hope this lesson worked out for you. Let me know if you have any questions next time you come into contact with me. All right, good luck.